Let's talk about abstract classes and interfaces. You can expand your custom libraries to have different classes with similar attributes, but having different implementations. For example, birds, horses, and fish all fit under the animal family, but birds have wings, horses have manes, and fish have neither. Abstract classes are generic and cannot be instantiated. If there are abstract methods that a subclass will override, they have no algorithm. The algorithms will be implemented in the subclass, and new attributes can be added to provide a unique implementation. Interface types are generic and only contain abstract methods, final constants, and final static fields. They are used to specify behavior that subclasses must implement. Interfaces overcome the one superclass limit as classes can implement multiple interfaces. For example, and this may sound silly, but bear with me, a mermaid class could implement both a person interface and a fish interface, providing both arms and tails. Subclasses can both extend base classes and implement one or more interfaces. Let's look at some examples. We have a test class that will implement a object of type circle, which extends shape. Shape is the abstract class, and it overrides both the area and perimeter abstract methods. We'll look at these in detail in just a second. We also have a object of type cube. It implements the geometric solid interface, and it overrides the volume and surface area methods. Finally, implementing cube using a default constructor and utilizing the setter to initialize edge length. We'll look at all of these in turn. Let's start with shape. Shape is an abstract class. You can see that it has the getters and setters. You can also see where it has some abstract methods, area and perimeter, that are not implemented. There's nothing just but the declaration. There's no algorithm associated with this. So when you implement this, you'll want to create those algorithms in the child class. And let's take a look at that. Next we have circle. Circle, indeed, in the area and the perimeter, it does create the algorithm, and we'll run through this in just a minute. You can take a look at what the output looks like. And then we also have the interface called geometric solid, and it has both a volume and surface area attributes. When you implement geometric solid, you must, we have volume and surface area, implement both the volume and surface area methods with an algorithm. Okay, and then finally we'll go through the test class. Again, we went over this in a little bit of detail. Let's just run through it. I'm just going to execute it, and we'll see what the output is, and that's what we would expect. I would suggest that you run through this in the debugger in detail. Spend a lot of time with this, get used to it. And what I would also tell you is that don't let the complex vocabulary throw you. Go through the zyBooks, run the sample code, and come back to the text after you have some experience with the programs. If it doesn't make sense right away, it'll come to you after some experience. Good luck.